Welcome to our Beer U module on yeast. Without yeast, there would be no beer or wine, so it's extremely important to brewers and vintners alike. In this module, we'll talk about what yeast are, where they come from, and how they do that voodoo that they do so well. Evidence of humans creating fermented beverages goes back thousands of years, at least to 7000 BC and the Jiahu archaeological site in China. Yet yeast were discovered to be critical for fermentation only around 1860. So how did so many brewers prior to 1860 know how to brew beer? For many ancient brewers, fermentation was just a happy circumstance. In fact, fermentation was probably discovered by accident when some ancient human left some wet grain or sugary drink lying around too long, which allowed it to ferment from naturally airborne yeast. Through trial and error, early humans probably discovered how to make such happy concoctions again and again until they were eventually able to start refining that process. Brewers got to be pretty good at creating better beer over the years by accidentally culturing yeast and helping them to evolve, all without the knowledge of the brewer. Despite a lack of understanding of fermentation, brewers could certainly tell which batches of beer they liked and which ones they didn't. Brewers often took samples from the batches they liked and used those samples as a source for the start of a new batch of beer. They might add a good sample into a new batch of beer, hoping that the qualities of the good sample would somehow transfer themselves to the new beer. In many cases, this worked because the yeast from the good sample would inhabit and reproduce in the new beer, making it a good beer as well. Similarly, brewers knew that some wooden barrels consistently made good beer, while others made bad beer. Sometimes brewers would use pieces of the good barrels to build new barrels. Because the yeast were inhabiting the wood itself, the good yeast from one barrel might get transferred to many new barrels in this process. In this way, brewers over the millennia have been influencing the evolution of yeast and creating better and better yeast strains, all without knowing what yeast were or that they had anything to do with making beer. Yeast are essential in making beer, wine, and bread. They are responsible for making alcohol and carbonation, so beer and wine would be pretty boring without it. Yeast are single-celled organisms and are classified as fungi, and they are literally everywhere. They live in wood, including tree bark and lumber, and they also live in the rinds and skins of many fruits. Yeasts love to eat sugar, and from that they produce CO2, or carbon dioxide, and alcohol. There are hundreds of varieties of known yeast, and probably many hundreds more varieties that have not even been cataloged. In 1860, Louis Pasteur's research led him to conclude that fermentation was the product of yeast. This contradicted the earlier misunderstanding that fermentation was a natural part of the life and death of ordinary cells. Later, Pasteur went on to define the fermentation process very specifically and was the first to determine that fermentation happened in the absence of oxygen and that yeast obtained energy by liberating oxygen from other substances, in this case, sugar. Pasteur also identified a large number of other microorganisms that were common infections in beer. His research helped brewers to understand the sources of those infections and eliminate them. Pasteur was not a beer drinker, but he set a goal for himself to help his native France to make the best beer in the world by helping French brewers compete with their German counterparts. Pasteur was pretty staunchly anti-German, since the Franco-Prussian War had seriously impacted his life and career. Pasteur set out to help French brewers create a beer of national revenge that would hurt Germany's primary export product, beer. Yeast are responsible for fermentation and producing alcohol and CO2 from sugar. This process is often expressed as a chemical formula that can look a little complicated, but is really quite simple. Yeast eat sugar, which is provided by malted barley in beer. They consume the sugar and produce two things that are important to beer, alcohol and CO2, or carbon dioxide. So there'd be no alcohol or carbonation in beer if it wasn't for yeast. Yeast generally reproduce by budding. Budding is when a single yeast cell splits into two yeast cells. The new, smaller cell is known as a daughter cell until it splits away from the parent yeast cell. Reproducing without a partner yeast is known as asexual reproduction and is common among various fungi. Under the right conditions, yeast can reproduce pretty rapidly, which means that a relatively small number of yeast can turn into a large number of yeast over a period of just a few days. Brewers typically begin their first batch of beer with yeast that they purchase from a yeast laboratory or another brewer. Once a brewer gets started with yeast, it can be grown or propagated in the brewery. Yeast can also be recovered after the fermentation process once it flocculates and settles out of the beer. The conical bottom of this fermentation tank is designed to catch the falling yeast and make them easier to recover. Yeast can be reused a number of times depending on the yeast, the desired results, and the way they are treated, but eventually all yeast mutate or start to lose their effectiveness in the brewing process and need to be replaced with fresh yeast that was cultured in a laboratory or in the brewery. Yeast enter the brewing process once the wort or raw beer is ready. That is usually after the boil process takes place, and once the wort is chilled to a low enough temperature that it won't kill the yeast when they are added. The process of adding yeast to the wort is known as pitching. Once they get into the wort, it takes the yeast a little while to get settled in. They feast on the nutrients in the wort and reproduce very rapidly until all the oxygen in the wort is depleted. Once the oxygen is gone, fermentation truly begins. With no oxygen left to them, the yeast begin feeding on the sugar in the wort, turning it into alcohol and carbon dioxide. Fermentation then usually takes several days to a week. Fermentation is essentially over when the yeast won't eat any more sugar. Once this happens, the yeast start to form into clumps and settle down to the bottom of the tank. This is called flocculation, and it's pretty handy for brewers because it makes it easier to recover the yeast and use them in another batch of beer. During fermentation, the yeast will eat much of the sugar, but not always all of it. The percentage of sugar that the yeast normally eat is referred to as attenuation. High attenuation means that most or all of the sugar has been eaten. Low attenuation means that a small amount of sugar has been eaten. Some beers, particularly Belgian-style beers, are bottle conditioned. This means that yeast have been added to the bottle and that the fermentation process will continue while the beer is being stored in that bottle. A little bit of wort is also added to give the yeast some sugar to eat. Wort, or unfermented beer, is a great source of sugar. The process of adding wort to a fermented beer is called krausening. Bottle conditioning provides additional carbonation since CO2 is still being produced by the yeast in the bottle. For larger size bottles, this can create a lot of pressure inside the bottle, so bottles are sometimes finished with a cork covered by a wire cage. Ordinary bottle caps might blow off the bottle due to the increased pressure that the bottle conditioning creates. Ale yeast, also known as Saccharomyces cerevisiae, are the classic beer yeast that have been around for millennia. They existed long before humans developed technology for refrigeration, which is good because they prefer warmer fermentation temperatures, usually around 55 to 70 degrees Fahrenheit. Ale yeasts do much of their work near the top of the fermentation tank. They tend to create a layer of foam on top of the beer, like the foam you can see in this picture. Ale yeast are used to brew ales and some hybrid beers. Ales tend to be more full-bodied with a wider range of flavors than lagers, partly because ale yeast produce more flavor components, called esters and phenols, than their lager yeast cousins. Lager yeast are more recent to the brewing scene. They started to be used somewhere around the year 1500. Unlike ale yeast, they do their best work at cooler temperatures from 45 to 55 degrees Fahrenheit. They've thrived in cool climates and become common since the advent of refrigeration. Lager yeast are called bottom fermenting because they tend to settle near the bottom of the fermentation tank to do their work. Modern lager yeast are called Saccharomyces pastorianus or Saccharomyces carlsbergensis. Both names refer to the same yeast species. Lager yeast are used to brew lagers, which are typically cleaner and crisper than ales. That's partly because the lager yeast produce fewer flavor components, like esters and phenols, than their ale cousins. Saccharomyces pastorianus, lager yeast, is a descendant of Saccharomyces cerevisiae and Saccharomyces eubayanus, something of a mystery yeast that might have come from South America. Prior to the year 1500, pretty much every beer that was brewed was an ale. That is to say, it was fermented with ale yeast at relatively warm temperatures. After or around 1500, German brewers began to brew lagers with yeast that liked cooler temperatures. and while ale and lager yeast behaved differently, it was presumed that they were essentially the same yeast species. They just liked to do things a little differently. In 2011, a study on a South American yeast was published. It contained the genetic code of a yeast strain native to the Patagonian forest that was found to be extremely similar to the genetic code of lager yeast. Researchers concluded that the two yeast were so similar that they must be related, despite being from different parts of the world. This led to the theory that the South American yeast must have traveled to Europe on trading ships, possibly in barrels made from Patagonian wood, with yeast living in it. This yeast is known as Saccharomyces eubayanus. Centuries ago, Saccharomyces eubayanus apparently made the trip from southern South America all the way to Europe. It's a little surprising because of the distance and the fact that lagers were being brewed in Europe by about the year 1500, a time at which travel between Europe and South America was very limited. But it is possible that eubayanus hitched a ride on a ship about that time. Once eubayanus got to Europe, it met Saccharomyces cerevisiae, the classic ale yeast. The two got together and produced Saccharomyces pastorianus, the modern lager yeast. There are hundreds of yeast species in the world, and some of them are used to do very specific things in the brewing process. Saccharomyces delbrueckii is a strain of ale yeast that tends to produce a high amount of esters and phenols. In many beers, this is a problem, but the flavors that this yeast tends to produce are the classic flavors of the German wheat beer called Weizen or Weissbier. Saccharomyces delbrueckii produces an ester compound that tastes of bananas and a phenol compound that tastes of cloves. Combined, these two flavors produce the signature taste of the German wheat. Brettanomyces, also known as Brett, are a yeast variant that are most commonly known to ruin or spoil beer. Brett can produce a number of unpleasant flavors and is widely regarded as a contaminant. However, Brett is used in small quantities in wine and in some Belgian-style beers to produce specific flavors. Commonly used variations of Brett in Belgium are Bruxellensis and Lambicus. Bruxellensis tends to produce a complex flavor known as barnyard or horse blanket, while Lambicus tends to produce fruity and tart flavors. These flavors would ruin most beers, but are prized in some traditional Belgian ales. Yeast can have significant health benefits and provide some very positive elements for your body. Yeast is full of B-complex vitamins, known to have a very positive impact on human energy levels. Yeast also brings with it a lot of chromium. Chromium is valuable in regulating blood sugar and cholesterol levels. Yeast also contains a lot of protein, which can help to reduce body fat. Yeast don't always create flavors in beer, but they do in some cases. Yeast flavors can be both desirable or undesirable. Yeast-produced flavors include esters, phenols, diacetyl, sulfur, and fusel alcohol. Esters are a compound produced by yeast that can produce flavors. To some degree, all beers contain yeast-produced esters, but in many beers, it's not enough to actually taste. Ales, in particular, tend to contain more esters than lagers, as the ale fermenting process is more conducive to producing them. Esters usually produce fruity, flowery, or spicy flavors. Banana and apple are two examples of flavors that esters can give to beer, but in large concentrations, esters can also produce a solvent-like flavor. Phenols are another yeast-produced compound that can provide flavors in beer, although sometimes other ingredients like malt can produce flavors that are easily confused with phenols. Phenolic flavors are usually undesirable flavors. Phenolic flavors are often described as spicy, smoky, medicinal, or even Band-Aid. While spicy or smoky flavors can be desirable, flavors like medicinal and Band-Aid are most definitely unpleasant. Lastly, we'll touch on another yeast-produced flavor compound that can be found in some beers, called diacetyl. All beers contain diacetyl at some point during the fermentation process. It's a natural emission from yeast. However, yeast will eventually consume and destroy diacetyl if treated properly, so diacetyl is almost always considered an off flavor in beer, although some beer styles allow for a small quantity of it. Diacetyl tastes buttery or sort of like butterscotch. It also tends to leave a slick coating on the tongue, and the presence of both the flavor and the slickness is a pretty sure indicator of the presence of diacetyl. Congratulations, you've finished the module. Hopefully you have a few minutes to take the optional quiz that is coming up. Like I said, it's optional, but if you are taking a Beer U curriculum and need to get credit for this module, you'll have to take the quiz and get at least 70% of the answers correct in order to show this module is complete. Good luck!